Hi and welcome back to Maths class. So in this video we're looking at displaying numerical data. We've just looked at categorical data in bar graphs and pie graphs. Now we're looking at numerical data, which of course we have two kinds. Discrete, which usually comes from counting. So if I count the number of people in your house, that will give me discrete data. If I count the number of pets that people have, that will give me discrete data. If I count the number of cars that drive by my house, discrete. If I'm measuring something, I get continuous. If I measure people's height, that will give me continuous data. If I weigh bags of flour, that will give me continuous data. So remember, discrete and continuous. Now, for discrete data, as you will see, the data can be grouped or ungrouped. But for continuous data, it always needs to be grouped, because for continuous data, even if I say I'm 137 centimeters, when I say something is 137 centimeters long, what I'm really saying is it's more than 136 and a half and it's less than 137 and a half. I'm rounding it already. So it would be unreasonable to call this discrete and therefore to just measure how many are exactly 137. Well, it's going to be none are exactly. They've all been rounded. So we always do continuous data in intervals. So when I want to display my data in a graph, I use a histogram. And a histogram looks a lot like a bar graph, but it's a little bit different. And we're going to look at some histograms in just a moment. We use it only for quantitative data, whether discrete or continuous. The bars touch in a histogram, and we'll talk about why that is in a moment. If I'm shading, I don't use separate colors because I don't have categories. I've just got numbers, so there's no need to distinguish between different categories using colors. And the heights of the bar, once again, can be frequency or percentage frequency, or relative frequency. I haven't mentioned that as well. All right, so first let's look at some histograms. On the left there, you can see some ungrouped discrete data that has been presented in a histogram. It's the number of cinema visits during a month. I can see that on my vertical axis I've got frequency, and so I can see that 6 people went no times to the cinema during that month, and it looks like 7 people went once, 4 people went twice, 2 people went 3 times, and 1 person went 4 times. That's my ungrouped data, where there is a separate column for every number. In the second histogram, I've got number of passengers on each of 20 trips. So this might be a bus, let's say, and someone counted the passengers on the bus for each trip. And I can see that there are no times when I had less than 5 passengers. But between 5 and 10, I've got 1. Between 10 and 15, I've got 6. Between 15 and 20, I've got 8. Between 20 and 25, I've got 4. And between 25 and 29, I've got 1 again. Now I'm just going to go back and we're going to look at my histogram checklist. First of all, if I want to get full marks on a test, I need all of these things. I need to write a title for my histogram. I need to label the axes clearly with scale, names, and units. So, for example, number of people, right? Or if it was measurement, I would write centimeters or kilograms. I need to have each column being of equal width. That's really important for a histogram. There's a different kind of graph which has a different width, and that's not a histogram. So make sure every column is the same width. The horizontal axis doesn't have to start at 0. It is a number line, but if my lowest value is 60, I don't need to leave a big gap in between 0 and 60. I can just start it at 60. Also, the graph doesn't touch the vertical axis. I need to leave approximately a half interval gap. So let's have a look at how that looks. You can see there that on the right, or in fact for both of them, I've left a gap in between the y-axis and the histogram. And notice where 0 is on the histogram on the left. It's right underneath the first column. So there is no sense in which this is not a Cartesian plane where 0, 0 is where the two axes meet, right? It's a totally different thing. Just going back up here again, we wanted to talk about why do the bars touch. Now, if we think about this being a number line, if I look at my second histogram, I couldn't put a gap in between the column from 5 to 10 and the column from 10 to 15. This is a number line and there isn't anything in between. So when I'm drawing a histogram, the columns always touch. And this is one way it's easy to quickly see whether something is a histogram or a bar chart. Now, what I've noticed here also is that for ungrouped data, that's what we've got on the left, the data labels are written underneath the center of each column. Whereas for my grouped data, it's the boundaries of the intervals that's marked under each column. So I don't mark 7.5, which is the middle of 5 and 10. I mark 5 on the left boundary and 10 on the right boundary. Now you guys might see in your textbook that at times the midpoint is marked, and we do that when we do a frequency polygon, which you'll see later. But I don't want you to do that at this stage. I just want you to label the boundaries. So we need to sometimes group our data into intervals. This is when I've got, let's say, a lot of numbers if it's discrete. For example, if I'm counting number of people in my house, I can count how many zeros, how many ones, how many twos, how many threes, how many fours, and how many fives, and that's probably all I'll get. But on the other hand, if I'm counting how many people are a certain age, and I've only got a collection of 20 people, it's not even necessarily true that I'll have 2 people the same age. So I group the data. How many people have I got between 20 and 30? How many have I got between 30 and 40? And so on. So what I do is I need to create somewhere between 5 to 12 groups, depending on how many numbers I've got. If I've got 100 numbers, it might make sense to do 12 groups. But if I've got 20 numbers, 12 groups is too many. I'll only have 2 people more or less in each group. So I'll go for something smaller. All right, we make a decision based on what we've got. And we do something logical. I don't just say, all right, I've got 20 numbers. I want 5 groups. Let's divide it by 4 and go up by 4s. I don't do that. I go up by 5s, by 10s, by 100s, by 0.5, etc. Now, when you're creating your intervals, make sure that every data point is included somewhere in your interval, and that they don't overlap. So I don't actually want one group of everyone between 5 and 10 and the next group between 10 and 15, because where do I put the person that's 10? In the first group or the second group? So what I'll do is I'll say 5 to 9 and then 10 to 14, something like that. Okay, it's not written here, but I need to make sure that every interval is of equal width as well. So what we're going to do here is for each question, I've got 3 questions. I need to decide whether the data is continuous or discrete. I need then to decide whether the data should be collated as grouped or ungrouped. And then if I decided it should be grouped, I'm going to choose my intervals, and I will show you how to do that. So for question 1, the following data shows the number of people living in each house in a survey of 30 households. So is this discrete or continuous? Well, the clue is where it says the number of people. I'm definitely counting there. So the number of people is going to be discrete. Okay, do I want to group this or not? My smallest number that I can see is a 1, and my largest number is a 5. Which means that even if I don't group my numbers, I've still only got 4 groups. I've got the 1s, the 2s, the 3s, the 4s, and the 5s. Sorry, that's 5 groups. I've got 5 groups. So I'm not going to group this data. Therefore, I don't need to go on and do part C. Question 2, the number of hours spent studying last week for 25 different students. So I need to decide, first of all, is this data continuous or discrete? And because I'm measuring something, that is time, this is actually continuous data. Even though it looks discrete, because there seems to be a gap of more or less 0.5 between most numbers, but then I can see that someone in there has written 2.3. But if I had measured more accurately, this definitely would be continuous data. So this is continuous, which means I don't have a choice. I'm not choosing between grouped and ungrouped. It must be grouped. All right, so how do I go about doing the grouping? Let's have a look. So when I look at the values I've got, I can see that the largest number there is 14 and the smallest is 0.5, which means my range is 14 minus 0.5, which is 13.5. So I've got a few choices here. I could go up by 5s, but then I would really only end up with 3 groups. I could go up by 4s, I could go up by 3s, or I could even go up by 2s. Now 2s seems quite good. That will give me 7 groups, 0 to 2, 0 to 1. Oh, I don't need, yes, I need to include 0 to, so from 0 to 2, from 2 to 4, 4 to 6, and so on. That's going to give me 7 groups. I'm going to go with that. So let's think about that. Now, I haven't done them all, but you can see there that I've gone from 0 up to less than 2, from 2 up to less than 4, from 4 up to less than 6, etc. Now I need to do it this way for continuous data, because if I just write from 0 to 1.5 and then I start at 2 on the next one, that doesn't include the number 1.6. So what if I go from 0 to 1.9? Well, that doesn't include the number 1.95. Well, if I go from 0 to 1.99, even though it's unlikely that I've measured in hours that accurately, theoretically it's still possible to have a number between 1.99 and 2. The only way for continuous data to get absolutely every number is to say I'm going from 0 up to everything less than 2, which includes 1.9999999999999 and so on. So the next category then starts at 2 and goes to less than 4. So where would I put the actual number 4? It wouldn't go in the 2 to less than 4 category. It would be counted in the 4 up to less than 6 category. Now I haven't listed all the categories, but I could keep going up to 10 to less than 12, and then 12 to less than 14. And I would need another one for 14 to less than 16. I can't include 14 in the less than 14, and I can't just make a bigger group to fit it in. I need to have all my spaces even, all my intervals of equal width. So if I look at the beginning and end of each of those intervals, if I do a subtraction, 2 minus 0 gives me 2, 4 minus 2 gives me 2, 10 minus 8 gives me 2. They're all a width of 2. All right, now let's look at the last question. No, we didn't actually make a histogram. We're just thinking about, do I group it or not, and how do I do it? So in the last question, I have the number of times per month that different Year 9 students went to the school library. And you can see we have some very regular library users here and a couple of big fat zeros. Now, my largest value here is 23, and my smallest value is 0. So even though this is discrete data, I don't want to have one category for every number. I'm going to group it. And because I'm going up to 23, going up by 5s, I think, is probably going to make a lot of sense. So you can see what I've done there is I haven't gone like I did in the continuous. I haven't gone 0 to 5 and then 5 to 9, because I need to know where to put the 5. Because I started at 0, I need to check that my intervals are all of equal width. Now, if I count how many numbers in each group, in the first group, I've got 0, 1, 2, 3, 4. In the second group, I've got 5, 6, 7, 8, 9. In the third group, I've got 10, 11, 12, 13, 14. There are 5 numbers in each group. Be really careful about that. People always make mistakes around the 0, or they think because I'm going up by 5s that I should have a subtraction of 5. But that's not the case. 4 minus 0 gives me 4. 9 minus 5 gives me 4. 14 minus 10 gives me 4. But actually my interval width here is 5, because there are 5 numbers if I count both the first and the last number. So there are my 5 groups for this group of data.